In this video, I'm going to demonstrate how to use this automotive test device, EM287. And at first look, maybe looks like a knockoff of a product called a power probe, except there are maybe enough differences so that they're not infringing on any patent rights. The power probe usually has a readout here, where this just has a string of lights. The power probe does have several different connector ends, where this only has these large battery clips, but I find those are really too large for my application. So the first thing I'm going to do is replace them with these smaller ones. And the smaller ones you can still connect to a deep cycle battery, plus you can connect to other power sources. So I'm going to remove these battery clips and install the smaller ones. We could potentially reuse these, but I'm not going to worry about it for now. So these are pretty easy to install. We want to put the boot on first, and then we're just going to solder it. And if you so desire, you can also put a crimp in them. It's just a simple matter of feeding this through. The EM287 is a diagnostic electrical troubleshooting tool. It can be used to check for shorts, opens, and quite a few other conditions. I have to emphasize that you really need to read the instructions well before using this, as you could potentially damage something if you misapply the probe. So keep the instructions handy and refer to them often. If you manage to short something out, there is an 8 amp auto reset circuit breaker that will hopefully prevent a catastrophic event. There is a tip probe, a ground lead, and supply wires, which will connect now. And when you connect it initially, it does a self-diagnostics test, which is what you just saw. The most basic function is a maintenance test light, and you just simply take the ground probe and touch it to this piece of metal here, and you'll turn on a diagnostics light. And the ground on the test clip is tied to the ground on the alligator clip. So this essentially is chassis ground if you're working on a vehicle or RV that does have ground tied to the chassis. There's a slide switch test in voltage, and if we put it in the voltage position, we can measure voltage. And I can demonstrate that here. And you see all 5 lights on the left are on and 2 lights on the bottom right are on. And that is just a voltage scale, so we see 12.5 volts lit here. That is not very accurate, as we are on the converter in the RV and producing 13.31 volts according to the Victron battery monitor. However, the next higher voltage LED on the probe is at 13.5 volts, so I suppose it's more of a matter of a limited resolution with the probe. All the other functions are on the test side of the switch, so we'll flip this to test. And that also activates this momentary switch. By flipping this switch back and forth, we're putting a positive or a ground on the probe. When the LED turns red, it is a positive voltage. When the LED is green, it is a negative voltage. Now, it may be a little bit difficult to remember red is positive and ground is green. Here's how I remember it. In a DC power line, red is always plus 12 volts. So when you get the red LED, you can equate that to the red wire or positive voltage. And then of course green is usually a green ground wire. So that's how you can remember it. I'm going to remove the fuse panel cover so that we can do some tests. Without touching the switch, which of course injects a voltage into the probe, we're going to do some continuity testing. And this is the positive side of the bus. On this circuit, we show a red or positive voltage. We have a positive voltage here. And we have a negative voltage here, which I'll explain later. On the ground side of the bus, we show negative. I remove the fuse from this fuse panel. And this normally would go to the fuse, this wire here, but it shows ground. The reason it shows ground is because it is reading through the light bulb to the ground, and the light bulb doesn't really offer that much resistance. So basically we're measuring ground through the light bulb. Now if I wanted to turn the light bulb on, I could hit the positive, and you see we inject a positive voltage into the light bulb. And then of course if we do a negative, it doesn't do anything because it's already at ground potential. And here's where you could get into trouble. If I tried that same thing on here, if I do a positive, it's okay. But if I select a negative, I'm going to blow this fuse. So you kind of have to know where you're at in the circuit as you're testing before you inject a voltage. And we can also do a continuity test on any device. For example, I have a fuse that is not connected to anything. I'll put the ground on one side, and when I touch the tip, you see that it measures ground on the other side, so we know this is good. Now again, if you put a positive on here, you're going to blow the fuse because it's going to run a positive voltage through here. A negative voltage though, no big deal, because of course this side is already negative. So if you're careful and do not depress the voltage switch, you can use this to test for continuity. And again, when we're troubleshooting, we can inject a positive voltage here to turn the light on. Or if I disconnect the ground wire on the light bulb and put a fuse back in, see now we see that this is at positive potential, because again, it's reading the positive voltage through the light bulb. And if I now inject a negative voltage, I can again light the light bulb. We can also use a probe to test the 7-pin cable. So we have battery, turn signal, brakes, ground, turn signal, taillights. And you notice we have nothing on the 2 turn signals. That's because these are LEDs. Being LED will not show up on this probe, but the taillights are incandescent. That's why the taillights show up. So again, you have to have some basic familiarity of what you're looking at. And I can turn the lights on by injecting the positive into the taillights, and I could actually turn the right and left turn signal through the LED. I wouldn't want to do that on the brake circuit though, because the brake circuits for a single axle trailer is about 6 amps, for a dual is 12, and this thing isn't going to supply that much power. So it's just like anything else, it's just another tool to help you with your testing. It's not very expensive, and in reality the only time you're going to get in trouble is by doing the voltage injection, so just be aware of that. Visit rv-project.com.